Okay, so from our graph, we get our definition of Hooke's law, and this is something you should learn off and be able to state word for word pretty much in an exam. So it just describes a graph. It says the extension of a spring is directly proportional to the force applied. And most people get that mark when they're asked to state Hooke's law, but they leave off the last bit here. Provided that the limit of proportionality is not exceeded. You need that last bit in because Hooke's law only holds true up to a particular force or load, and then after that we can't use it and we can't apply it. So from that we can write that force is directly proportional to extension. Okay, and what we do if two things are directly proportional is we can replace this little symbol that means direct proportionality, and you will be doing this in maths soon enough, with an equals k sign. So any two things that are directly proportional can be related by this type of equation. One variable equals a constant times another variable. Okay, and this is Hooke's law written as an equation. Okay, in the same way we can state Newton's second law, but it's much easier writing RF equals MA than putting it in words. Okay, so this is Hooke's law. This is the load, which should be measured in newtons. This is the extension, which could be measured in millimeters, centimeters, meters, but most often it would be in centimeters. And K here is what's called the spring constant. And each spring will have a particular spring constant. So the springs they use in suspension in cars will be very different to the springs you used in the experiment today. Now, if we look at that equation, I can rearrange that to give me K is equal to F divided by E. And if I look at the units then for that equation, that would be newtons per centimeter. So if I work out my value of K and I find out it's 3 newtons per centimeter, what that value of K means is it's the number of newtons required to produce an extension of 1 centimeter. Okay, so for instance, if I wanted an extension of 2 centimeters, I would need 6 newtons. Okay, so it's the number of newtons needed per centimeter of extension. If you look at your graph, okay, so we have that K is equal to F divided by E. If in this limit of, up to this limit of proportionality, I do work out the gradient and say that is rise over run. Can everybody see if I worked out the rise? That would be a load or a force divided by the run, which would be an extension. Force divided by extension is K. That's why we do our graph that way round. Okay, because if we draw it with the unusually independent variable here and dependent variable in the x-axis, then we will work out the gradient. The gradient gives us the spring constant. Okay, so the gradient of the graph you just drew gives you your spring constant.